scientists have proposed a new theory that could rewrite the timeline of the Chernobyl disaster. After eyewitnesses reported seeing two major explosions on April 26, 1986, it's widely been believed that the first of these was a blast of steam caused by energy from the hot cooling water and a nuclear surge across the reactor core. The new analysis, however, suggests a nuclear explosion came first. This explosive event within the reactor would have launched ejected debris as high as 3,000 meters, followed by the steam explosion that would have caused the reactor to rupture. Researchers analyzed xenon isotopes detected by scientists from V.G.Khlopin Radium Institute in the Leningrad 4 days after the accident. These were found far from the site of the disaster itself, at a city called Cherepovets, north of Moscow, and far from the major track of the debris. According to the researchers, these isotopes would have been created by recent nuclear fission, indicating a nuclear explosion. According to the new analysis, the observations of the destroyed reactor tank are also indicative of a nuclear explosion, followed by a steam explosion. This would have caused temperatures to climb high enough to melt the 2-meter-thick bottom plate in the southeastern part of the core, which had reportedly disappeared. Witnesses at the time reported a blue flash above the reactor seconds after the first explosion, which the researchers say supports the new timeline. In a study published to the journal Nuclear Technology, researchers from the Swedish Defence Research Agency, Swedish Meteorological and Hydrological Institute, and Stockholm University analysed xenon isotopes detected by scientists from V.G.Khlopin Radium Institute in the Leningrad 4 days after the accident. These isotopes were found far from the site of the disaster itself, at a city called Cherepovets, north of Moscow, and far from the major track of the debris. According to the researchers, these isotopes would have been created by recent nuclear fission, indicating a nuclear explosion. The main debris, on the other hand, contained equilibrium xenon isotopes from the reactor's core. This material was found northwest of the site, in Scandinavia.An. Assessment of the weather conditions from the time suggests the fresh xenon isotopes found at Cherepovets came from debris launched higher into the sky than that from the reactor rupture. According to the researchers, a nuclear explosion would have ejected the debris to much higher altitudes than the steam explosion. We believe that thermal neutron-mediated nuclear explosions at the bottom of a number of fuel channels in the reactor caused a jet of debris to shoot upwards through the refuelling tubes. This jet then rammed the tube's 350 kilograms plugs, continued through the roof and traveled into the atmosphere to altitudes of 2.53 kilometers, where the weather conditions provided a route to Cherepovets. The steam explosion which ruptured the reactor vessel occurred some 2 7 seconds later. According to the new analysis, the observations of the destroyed reactor tank are also indicative of a nuclear explosion, followed by a steam explosion. This would have caused temperatures to climb high enough to melt the 2-meter thick bottom plate in the southeastern part of the core, which had reportedly disappeared. On April 26, 1986, a power station on the outskirts of Pripyat suffered a massive accident in which one of the reactors caught fire and exploded, spreading radioactive material into the surroundings. More than 160,000 residents of the town and surrounding areas had to be evacuated and have been unable to return, leaving the former Soviet site as a radioactive ghost town. A map of the Chernobyl exclusion zone is pictured above. The ghost town of Pripyat sits nearby the site of the disaster. The exclusion zone, which covers a substantial area in Ukraine and some of bordering Belarus, will remain in effect for generations to come, until radiation levels fall to safe enough levels. The region is called a dead zone due to the extensive radiation which persists. However, the proliferation of wildlife in the area contradicts this, and many argue that the region should be given over to the animals which have become established in the area, creating a radioactive protected wildlife reserve. Burn throw observed in the sub-instrumentation room below suggests there were brief and sharply directed streams of high-temperature plasma entering from above, the researchers wrote in the study. This strongly supports the hypothesis of a much stronger plasma jet aimed in the opposite direction where, because of the refueling tubes through the 4 meters thick upper plate, there was substantially less resistance. In other parts of the core, the bottom plate had remained mostly intact, but it had dropped by roughly 4 meters. This was likely caused by the second explosion, a steam explosion which generated enough pressure to push the plate down without getting hot enough to melt it. The steam also launched the 2,000-ton top plate roughly 20–30 meters above the floor. Witnesses at the time reported a blue flash above the reactor seconds after the first explosion, which the researchers say supports the new timeline.